have a lot of white buildings and white roofs, and they're there for a reason. And so a couple of things you want to look at basically is your solar reflectance and your solar emittance. So the solar reflectance is the fraction of solar energy that is reflected by the roof, and your thermal emittance is the relative ability of the roof surface to radiate and absorb that heat. So for compliance modeling, and when you're putting when you're doing modeling for the program, you're going to want to use the age reflected numbers. So there's a website called the Cool Roof Rating Council. It's called www.coolroofs.com. You can go there and you can select or find products. If you get a spec from a builder and they're saying this is the roof we're going to go for, you know, it's a GAF roof or whatever it may be, you can go in there and look at it online, obtain that Cool Roof Rating Council basically rating of the roof. It's similar to the National Fenestration Rating Council, how they rate windows. These guys rate roofing products, and you can get that age reflectance value there. So depending on where you are, again, as climate zones in California, cool roofs may not be effective. You know, in a heating dominant climate, so where it's really cold outside, cool roof typically will then increase your energy use, you know, because you're not allowing that heat to come through when you want it, when you need it. So as a cost effectiveness kind of, if you're analyzing the cost benefit for a cool roof, you may see very little or no cost benefit when installing a cool roof in a heating climate or heating dominant climate. Attic radiant barriers. Similar to cool roofs, attic radiant barriers are most effective during the cooling season, so it's reducing the summer attic temperature. And for the CEC, they basically say climate zones 2, 4, and 8 through 15, they all should, if you're re-roofing or doing something with your roof, you're going to require a radiant barrier. And that's because those climate zones have a lot of cooling requirements in the summer months. So radiant barriers, they come in a couple different types. You know, obviously, depending on the manufacturer, they might, if it could be right at cool roof, attic radiant barrier could be adhered to the one side of your plywood, your sheathing that's going up on your roofing. So you may be able to get that continuous radiant barrier through a certain product. Now, if you're retrofitting an attic, or if the client is trying to, you know, they're not going to be taking off the sheathing, or they're not doing anything to the sheathing, you can then do what's called the existing roof sheathing. So this is where it's not going to be continuous. So you have your roof rafters that are directly on your roof sheathing, and then between those rafters is where you're then going to be putting in your attic radiant barrier. Both are very effective. Obviously, the continuous is more effective than the kind of retrofit existing roof sheathing, because you still have that small area where the rafters are connected to the sheathing, and it's transferring that heat. The continuous is kind of, think of it as a thermal bridging kind of, you know, reducing that thermal bridging, whereby when you do existing, that thermal bridging is still happening, but it's definitely going to give you an impact. So here in EnergyPro is where you would do it. So you have your component description, very similar screen as you saw on the walls. But here's where you would be putting it in. If it is going to be a cool roof and it's a certified roofing product, which means you found it on the CRRC website, you then select that box and you plug in those numbers that you get. If you're going to have a radiant barrier and it's an existing roof, so it's going to be over the skip sheathing. The other option that you would find in this drop down will be just the continuous option. Another thing about attic radiant barriers and the products and manufacturers will give you some kind of attic venting requirements. So they'll try to show you how this product is going to be best optimized on your building. You still need to have proper ventilation in your attic. You know, it's not going to, your attic's not going to be as comfortable to be in as the rest of your home. And if you don't have proper ventilation, it's never going to be that way. But you are going to try to reduce that attic heat. And then, so proper attic ventilation is going to be kind of important and should be discussed to the design team when they're doing these kind of retrofits. And you can plug in that percentage of vents, you know, that are high. So they want you to have high vents and low vents, so the air moves out of there. You know, heat rises, right? So they want to take, you know, if you have eave vents, that's going to be the low. It's going to take that vent. You're going to have a little baffle there under your eave vents that blocks, you know, so the insulation doesn't block it. It's going to let that air come through and pass through the roof and then go out the roof, the vents at the high point of your roof. Typically, the vents at the high point of the roof are, you know, you may have like 30% open or whatnot. The 1 per 150, that's basically saying 1 square foot of open attic vent per 150 square feet of attic area. Again, you go to the EnergyPro and kind of click on those things and hit on F1, and it'll give you a little bit more of a description. But for the most part, this information of attic venting could be found by the manufacturer, or obviously if your design team is savvy enough, they might be already, you know, all over it, and they can give you those numbers off the top of their plans. So summary slide, depending on where you are in the climate zone, your building is located, cool roof may or may not be cost effective. So when you're doing that cost analysis, make sure you're kind of looking at those things. Go to the Cool Roof Rating Council's website at www.coolroofs.com. Attic radiant barriers are most effective during the cooling season, and radiant barriers can be installed over existing roof sheathing or continuous. Excuse me. So we're going to talk about added insulation, and so here, if you guys have been and girls have been kind of keeping up in the building energy efficiency standards, their overall U factors of walls have gotten pretty, I guess, stringent, you could say, and is a good thing. But a lot of them are going to require, to meet it, you're basically going to require to have an exterior rigid insulation of some sort. I believe it's 0.065 is the U factor of walls now, and so I wanted to just kind of touch on added insulation and how to do that. So you can add insulation to the interior or exterior, and this is going to be added insulation on top of what your 2x4, 2x6 assembly is. So you may have the need to use furring strips. So basically, where it says framing here, that's called the framing type, and it could be wood or metal. You may see this if you do any properties that have basements that are habitable spaces and there may be CMU blocks. They may want to put added insulation on the CMU blocks, and so the way to get that insulation in there would be to put up 2x4s, and that would be technically your furring, and then you would put your insulation in between there, and put your drywall on, and blah blah blah. You can basically close up the wall that way. So you could select wood or metal, as I said, and then where it says insulation, that's the R value of insulation that you're going to be putting into the wall. And the thickness, that's going to refer to the framing member, not the thickness of the insulation, but the framing member that you're adding as your furring. I'll show you kind of some examples here. So I've taken an R3 wall, R13 wall, and there's no added insulation. So 0.102 is your overall U factor. Overall R value is 0.98. So that's basically being derated because of the thermal conductivity between the studs, right? Now, if you have over here on the right, you have the same R13 wall, and you're adding insulation of an R5 value, and I'm saying it's a 2x4 framing member, so 3 inches, or 3.5 inches, technically, 3.5 inches furring added, and so you're adding from you're reducing your U factor, so lower is better, right? So 0.102 goes down to 0.067, and then even to down here, I'm showing without the wood framing, so I have no furring going on here. Same insulation value, and as you can see, when it went to none, the thickness grays out. You're at 0.068. So yeah, you're getting a little bit of a difference when you don't have the framing member. It's not much, but depends on how big your wall is, and it might make a big effect on it. So that's where you would do your added insulation. Looking at your plans, or looking at the scope of work, you might see that they're going to do rigid or something like that, and you might say, okay, how is this going to, you're going to have to ask these questions, like how are you going to construct it, show me the details on how it's getting built, so you can model it with accuracy. And I guess we'll move on, last but not least, I think, as my thermal mass discussion. So thermal mass basically is the ability of a material to absorb and store heat energy. And thermal mass is most useful in locations which large swings of temperatures from day and night. So, deserts, or just, I don't know, any place that has a large swing of temperature. Between the day and night, you want to store that heat that thermal mass is going to absorb during the summer or during the daytime, and then at night, as the building cools down, the heat then will radiate out of that material. Depending on the type of material, that's going to radiate that heat, quicker or faster. Concrete holds that heat in for longer than, say, wood. So you can check that kind of stuff out. In the joint appendice, for residential joint appendice, it gives you a good explanation of kind of materials and properties and things of that nature. So how to input it into EnergyPro? So first off the bat, when you're dealing with slab on grade, there's already a thermal mass calculation going on in EnergyPro. So I wanted to show you this slide because basically, as you can see, I'm selected down here. I've selected on the slab on grade, and over here it doesn't give you a mass type because it just knows it's the concrete. You may change your thickness, and you may change if it's exposed or not, but there's already a default slab on grade thermal mass calculation going on there. So to count for thermal mass, you need to actually put it in as a raised floor. So there's potentially, well, I'll get in that a second. So you add in a raised floor, and you get these selections, these types of selections of a material that floor is from the drop down. So this drop down will not be gray anymore, and you're in raised floor, and you can now select from these types of materials. And as I said before, the joint appendice, the CEC reference appendice, has more information of those material types. So here we've entered it as concrete heavyweight, and we're saying it's 4 inches thick, and it's an exposed material, meaning it's exposed to the sun. Or if the mass is covered by carpet, cabinets, anything fixed to the space or to the room, then you're going to have to model that area separately. You should only be modeling for thermal mass, you should only be modeling the area that is exposed. So potentially, you're going to have multiple floors or floor types when you're trying to accurately model thermal mass. So summary slide, thermal mass floors need to be inputted as raised floors. Only account for the area that is exposed. May need multiple floors depending on where the thermal mass is located. And refer to the joint appendices for more information on those material types. And don't forget to click Expose button to take the credit. So basically, we're at the end of the slides. These are a few architectural building features that I see out there that are coming more prevalent in the built world, the built environment. And as we try to lower our energy consumption and energy use, we really need to start taking into consideration these architectural building features to right-size equipment. And as we get into if you ever deal with passive solar or passive house, these things are going to be all over the place for that. And you're going to want to really hone in on them because the value that you're going to have for your client is going to be way better than if they, no disrespect to any mechanical engineers out there, but just grab the mechanical engineer and say, can you do a Title 24 for me? They give them a Title 24 and they say their load requires a 4-ton HVAC system, and they go back and say, well, this is supposed to be, a sustainable passive house, no HVAC. So as energy consultants, we really want to, we want to do the right thing and model these things with accuracy as much as we can. May take a little bit more time, but the end outcome is good for you, your client, and the built environment we live in. So with that, are there any questions, Mike?
Yeah, there's one question, and it's a pretty valid question, but unfortunately we can't really accommodate it. The question is, can you update the screenshots and the presentation to refine or revise this discussion to cover EnergyPro 6? The Multifamily Upgrade Program is exclusively running EnergyPro 5 for its models and methods, so the presentation is meant to help you apply to and participate in the Multifamily Upgrade Program. If you need some advice or if you need some help with EnergyPro 6, you are welcome to reach out to us here at the program, and we can try and find the right person for you to speak with. Alternatively, I'll leave it up to you, Kyle, if you want to mention anything about the differences between.
Yeah, I know there are, and and I know there's a couple of things in there, like for one, the non-solar walls, that whole making it one reflective surface isn't there anymore for EnergyPro 6, but as Mike said, I don't want to confuse people on these slides. I'm sticking to the EP5 and the way that how we handle it in that model. There is other workarounds for EP6, but yeah, we're just trying to keep it simple in the EP5 world for the program. So sorry about that. It's a valid question, but. Any other questions, Mike?
Sure, no problem. The questioner just said thank you, so no problem about that. Sorry about the confusion, but yeah, we're going to stick with EnergyPro 5 for this program. There are no other questions at this in the chat, so if there are no further questions, we can go ahead and adjourn early. So I want to say, Kyle, this was really helpful and informative for me, so thanks for taking the time to put together the screenshots, and if there's any final words you'd like to say before I close the webinar, please feel free.
Okay. No, there's nothing really. I just, I just know that the energy codes, everybody should be up on the energy codes, I'm sure, at least pay some kind of attention to it. As we strive for this zero net energy, and I know we're kind of being specific to the program, but obviously the program's going to evolve as the code evolves. So I think knowing how to capitalize on architectural features such as the ones we discussed here today, and I'm sure there's plenty more, it's going to be more important as we move on in the program and in the code.
Thanks, Kyle. Everybody,
Right,
you will be prompted to take a little survey and give us your BPI registration number. If you'd like to receive continuing education credits for this training, please fill out that survey at the end of this webinar. Thanks, everyone, for your time.
Bye-bye.